Well, this one here looks like quite the doozy. Let's see here. Well, I have square roots on both sides, so I'm not able to like just divide by 2 and get, a number or whatever. So I might just have to go ahead and square both sides right off the bat. Now, we can do that. All right? But what's going to happen here is I'm going to square the 2 and I'm going to square the square root. Oh, you can't distribute. Yes, you can, because I just have multiplication here. In here, the addition is protected by that square root, the radical there, the house. So that's okay for this one. So I'm going to have 4 times 3x plus 1 equals, and then I'm going to have 8. And I'm going to show you a way to do it where we divide as well, and you can decide which way you like better. All right, so from here, I could divide by 4, make things a little bit easier. The only reason why I did that is because I have an 8 here, it's divisible by 4. If I had a 9, I would have just distributed the 4 here. But because it's an 8 and it's divisible by 4, now I'm working with smaller numbers. So I'm going to have 3x plus 1 equals 2. I'm going to subtract 1, and I get 3x equals 1, so x equals 1/3. Awesome. Let's see if this is all right. If I plug it in, I'm going to have, so your 3 times 1/3 gives me 1. 1 plus 1 gives me 2. So I have 2 root 2. I know that the square root of 8 simplifies to 2 root 2, so we are good to go, Cotton Eye Joe. All right, let's see about the other way. Now, most of you might not have noticed this, but it is still kind of cool to look at. If I have 2 and then times the square root of 3x plus 1 equals, and if I simplify the square root of 8, that breaks down to 4 and 2, so I get 2 root 2. Well, what can I do with these 2's? Cancel. Now I can just square both sides without those 2's there, and I'm left with 3x plus 1 equals dose. Subtract the 1. Oh yeah, now it's looking familiar, and I get x equals 1/3 when I divide by 3. Look at that. Same answer, different path. That's math. That's power. That's just good old American muscle.